Hello. We will now begin Unit 3 of our course. You remember in the first unit, in the second lesson, I think, we had an introduction to exponents. We spent a few minutes talking about exponents, what exponents are, and how they are represented, what are their main properties. In this lesson, we will continue with the study of exponents by discussing three important rules for simplifying exponents. Now, we will do that in the first three lessons of this unit. In this lesson, we will look at product rule and power rule for simplifying exponents. Okay, let's start. Now, in the expression, you know, x to the power of n, what do you call x? X is called the base, and n is called the exponent. Now, what is the value of x to the power of 2 multiplied by x to the power of 3? Tell me, what is that? X to the power of 2. X to the power of 2 is x times x. X to the power of 3 is x times x times x. Now, how many times are we now multiplying x by itself? There are 5 of them. So, you can now say x to the power of 2 multiplied by x to the power of 3 is x to the power of 2 plus 3. There are 5 of them, and that is equal to x to the power of 5. So what does that tell you? It tells you that when you multiply exponents with the same base, what all you need to do is add the exponents. X to the power of 2 multiplied by x to the power of 3 equal to x to the power of 5. X to the power of 2 plus 3. Tell me, what will then this be? 2 to the power of 3 multiplied by 2 to the power of 4 will be 2 to the power of 3 is 2 multiplied by itself 3 times, and 2 to the power of 4 is 2 multiplied by itself 4 times. And now, how many 2's are now multiplied? There are 3 plus 4, 7. 2 is multiplied by itself 7 times, and the 7 is obtained by adding the two exponents, 3 plus 4. So what is the simplified form of 2 to the power of 3 multiplied by 2 to the power of 4? It is 2 to the power of 3 plus 4, and that is 2 to the power of 7. Now, this leads us to what is called the product rule for exponents. What is the product rule for exponents? When expressions with the same base, very important to note that, when expressions with the same base are multiplied, the exponents are added. And this is called the product rule for exponents. Now, the product rule for exponents can be written in a general form like this. X raised to the power of m multiplied by x raised to the power of n can be obtained by raising x to the power of m plus n. A very important rule. Okay, quickly let me ask you then, what is the value of a to the power of 7 times a to the power of 9? Can you use the product rule to simplify this? What is a to the power of 7 multiplied by a to the power of 9? That will be equal to a to the power of 7 plus 9 That will be a to the power of 16. I hope you understand this. That is power rule, and that we will be using very often as we move on. Okay, write using exponents 1 over 3 times 3 times 3 times 3. Can you write that using exponents? What is the denominator? The denominator is 3 multiplied by itself 4 times. So that is 3 raised to the power of 4. So 1 over 3 raised to the power of 4 is this. Another one. Write using exponents 1/2 multiplied by 1/2. How many times is 1/2 multiplied by itself? There are 5 times. So this is the same as 1 over 2 raised to the power of 5. Now look at the way we write it. The quantity 1 over 2 in parentheses raised to the power of 5. In other words, it is that quantity 1 over 2 repeatedly multiplied 5 times. Alright? And this is the same as 1 to the power of 5 divided by 2 to the power of 5. It's a very important property. For example, watch this now. If I have, if I have a 4 divided by, if I have 4 divided by 3 all to the power of 5, that can be written as 4 to the power of 5 divided by 3 to the power of 5. In other words, when a quantity like this is raised to a power, the power belongs to each of these. 4 over 3 raised to the power of 5 is 4 to the power of 5 divided by 3 to the power of 5. Okay, let's move on. Find the value of 3 to the power of 2 multiplied by 3 to the power of 3. I'm sure you can do that without any trouble. When expressions with the same base are multiplied, what all you need to do is add the exponents. So 3 to the power of 2 multiplied by 3 to the power of 3 equal to 3 to the power of 2 plus 3. That is equal to 3 to the power of 5. Can you work it out for me? What is 3 to the power of 5? Watch this. 3 multiplied by 3 is 9. 9 multiplied by 3 is 27. 27 multiplied by 3. Anybody knows what is 27 multiplied by 3? It's 81. 81 multiplied by 3. Can you work out that in your mind? 81 multiplied by 3 is 243. So the value of 3 to the power of 5 is 243. It's good to know, become familiarized with these kind of numbers. Alright, tell me, what is 3 to the power of 4? 3 to the power of 4 is 3 times 3 times 3 times 3. That is 81. 3 to the power of 3 is 27. Okay? Alright, let's move on. Find the value of 5 to the power of 3 times 5 to the power of 5 times 5 to the power of 7. Now here, you have 3 expressions with the same base multiplied. What will this be? This will be the same base raised to the power of 3 plus 5 plus 7. When expressions with the same base are multiplied, you raise that base to the sum of the powers. So 5 to the power of 3 times 5 to the power of 5 times 5 to the power of 7 is 5 to the power of 3 plus 5 plus 7, and that is 5 to the power of 15. If I ask you to give me the value of 5 to the power of 15, I don't think that is reasonable. I don't think you can work it out. 5 multiplied by itself 15 times. It's going to be a very huge number. So I will not ask you for that. But I will be asking you sometime, what is the value of 5 to the power of 3? Can you tell me that? What is 5 to the power of 3? 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. What is 5 to the power of 4? 125 times 5 is 625. Okay, those simple numbers you must know. Okay, let's do another one. Find the value of, now I want you to watch this, negative 9 raised to the power of 8 multiplied by negative 9 raised to the power of 7. Well, you know that a negative number multiplied by a negative number is a positive number. Okay, let me ask you this now. What is negative 2 raised to the power of 2? It is negative 2 multiplied by negative 2. And what is negative 2 multiplied by negative 2? I want you to watch carefully how I write it. This negative 2 is in parentheses. That means it is the negative 2 that is repeatedly multiplied. Negative 2 multiplied by itself twice. A negative number multiplied by a negative number is a positive number. So negative 2 raised to the power of 2 is negative 2 times negative 2, that is positive 4. On the other hand, what is negative 2 raised to the power of 3? That will be negative 2 multiplied by negative 2 multiplied by negative 2. You are multiplying negative 2 by itself 3 times. Now tell me, what will be the sign of this number? A negative 2 multiplied by a negative 2 will be a positive 4, and a positive 4 multiplied by negative 2 will be negative 8. So the value of this will be negative 8. So when a negative number is raised to an odd power, I want you to watch this and learn it. When a negative number is raised to an odd power, the answer will be negative. Whereas when a negative number is raised to an even power, you see 2, 4, 6, 8 and so on, the result will be positive. For example, negative 2 raised to the power of 10. Now tell me, is this going to be positive or negative? You are raising the negative 2 to a power 10. That means you are multiplying negative 2 by itself 10 times. The result will become positive. Now you must know this. I'm going to repeat this one more time. When a negative number is raised to an odd power, the result will be negative. When a negative number is raised to an even power, the result will be positive. Okay, can you look at the question here and tell me, negative 9 raised to the power of 8, will that be positive or negative? I don't want you to give me the answer. Just tell me, will the results be positive or negative? A negative number is raised to an even power, that will be positive. On the other hand, The next one, negative 9 raised to the power 7. Will the result be negative or positive for that? A negative number is raised to an odd power. The result will be negative. Okay, in that case, in this question, this will be a positive number and this will be a negative number. Therefore, what will be the sign of the whole result of this problem? Will be a positive multiplied by a negative will be negative. Okay, I want you to answer one more question before I start doing this. And that is, watch this. What is negative 2 to the power of 2? I want you to distinguish between this negative 2 raised to the power of 2 and negative 2 raised to the power of 2. Now you must understand here, this power 2 does not belong to the negative sign. Whereas in here, the power belongs to the whole of negative 2. In the bottom one, the power only belongs to 2, not the negative. That means the negative will not get multiplied twice. The negative will simply remain negative. So, negative 2 squared is the same as negative 2 times 2. That is negative 4. So, I want you to understand the difference between when you write a negative number inside a parenthesis and raise it to a power. Now, when the negative number is written inside a parenthesis and raised it to a power, it is the negative number will get multiplied that many times. If the negative number is not in a parenthesis, then the power only belongs to the number, not to the negative sign. So negative 2 squared is negative 2 times 2, that is negative 4. So look at the difference in the way I read it. How do I read this? Negative 2 raised to the power of 2. And that is negative 2 times negative 2, positive 4. How do I read this? Negative 2 squared, and that will be negative 2 times 2, that is negative 4. Now please don't forget, do not confuse here the difference between this and this. Okay, let's move on and do this problem. Find the value of negative 9, look at the way I read it, negative 9 raised to the power of 8 multiplied by negative 9 raised to the power of 7. Well, the base is the same, therefore you add the exponents. This will be negative 9 raised to the power of 8 plus 7. That is negative 9 raised to the power of 15. Well, a negative number is raised to an odd power. The result will be negative. So this is negative 9 to the power of 15. You see, now I have taken away the parenthesis. This is now negative 9 to the power of 15. The result is negative. When the power of a negative number is odd, the result will be negative. Alright, let's find the value of this. What is the value of negative 2? Again, listen to the way I read it. Negative 2 raised to the power of 5 multiplied by negative 2 raised to the power of 5. Alright, tell me, what will be the sign of negative 2 raised to the power of 5? A negative number is raised to an odd power will be negative. Similarly, this will be negative. And so in the answer, a negative multiplied by a negative becomes positive. Alright, let's simplify this using the product rule. negative 2 raised to the power of 5 multiplied by negative 2 raised to the power of 5 will be what? Will be negative 2 raised to the power of 5 plus 5, and that is negative 2 raised to the power of 10. Now you have the result. A negative number is raised to an even number. The result will be positive. So how will I write it? That will be 2 to the power of 10. That will be positive. Okay? When the power of a negative number is even, like this, negative 2 to the power of 10, the result will be positive. Find the value of 5x, quantity 5x, raised to the power of 2. Now, when you have a quantity enclosed in a parenthesis and raised it to a power, the power belongs to each of the numbers in there. In other words, it means 5 is raised to the power of 2, and also x is raised to the power of 2. That is the meaning there. So the quantity 5x, all raised to the power of 2, is the same as 5 raised to the power of 2 times x raised to the power of 2. Now, 5 raised to the power of 2 is 25, so that will be 25x squared. Another one. Okay, look at this again. A negative quantity raised to the power of 4. Negative 2x, the quantity negative 2x raised to the power of 4. Now, this can be interpreted as the number negative 2 raised to the power of 4. Can you understand that? This is take negative 2 and raise it to the power of 4, then multiplied by x raised to the power of 4. Okay, what is the number negative 2 raised to the power of 4? First of all, tell me, will that be positive or negative? A negative number raised to the power of 4 will be positive. Alright, what is the value of 2 raised to the power of 4? 2 times 2 times 2 times 2. What is the value of that? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So, negative 2 raised to the power of 4 is 16. The same as 2 raised to the power of 4 is 16. So that will be 16x to the power of 4. Okay? Another one. Find the value of 3 over 4 all raised to the power of 3. I explained one like this before. This power 3 belongs to the numerator as well as the denominator. So what this means is 3 raised to the power of 3 divided by 4 raised to the power of 3. Alright, so that will be 3 to the power of 3 over 4 to the power of 3. Tell me, what is 3 to the power of 3? We did that some time ago. 3 to the power of 3 is 3 times 3 times 3. That is 27. Can you tell me what is 4 to the power of 3? You must be familiar with these numbers. 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. 4 to the power of 3 is 64. So this will be 27 divided by 64. Let's go on. Find the value of, watch again here, the quantity negative 8r raised to the power of 4 multiplied by the quantity negative 2r raised to the power of 3. Now how will you simplify that? Now what we're going to do is, first, in each of these quantity, give the powers to each of the numbers. So watch here carefully. The quantity negative 8r raised to the power of 4 is the same as the number negative 8, put that in parentheses. You are raising the power negative 8. The number negative 8 raised to the power of 4 multiplied by r raised to the power of 4. Now, this is multiplied by, what is this? The quantity negative 2r raised to the power of 3 is the number negative 2 raised to the power of 3 multiplied by r raised to the power of 3. Okay? Now, what is the next thing to do? Let's simplify this. Negative 8 raised to the power of 4, a negative number is raised to an even power, the result will be positive. So negative 8 raised to the power of 4 is 8 to the power of 4. So this will be 8 to the power of 4 multiplied by r to the power of 4. And in the next one, negative 2 raised to the power of 3. A negative number is raised to an odd power, the result will be negative. Negative 2 times negative 2 times negative 2 is negative 8. Put that in the parenthesis. So this will be negative 8 times r cubed. Now, to simplify a quantity like this, you must now combine like terms. Now, if you notice, this is 8 to the power of 4, and this is negative 8. The bases are the same. So, like terms means terms that contains the same basis. Can you tell me, what is 8 to the power of 4 multiplied by negative 8? First of all, you are multiplying a positive number with a negative number. The result will be negative. So, this will be like this. 8 to the power of 4 times negative 8 is the same as negative. You see, you are multiplying a positive number with a negative number. The result will be negative. That will be negative 8 to the power of 4 times 8 to the power of 1. That is negative 8 to the power of 5, isn't it? This makes the whole quantity negative. 8 to the power of 4 times, we have taken care of the negative there. That means you got an 8 to the power of 1 left there. And that is equal to negative 8, the same base, raised to the power of 4 plus 1, 5. So these two will combine to give me negative 8 to the power of 5. And then you can combine r to the power of 4 and r to the power of 3. What will that be? The base is r, so we group like terms. That will be here 8 to the power of 4 times negative 8. That means we wrote the expressions with base 8 together. And now we combine expressions with the base r together. And we now know that this is negative 8 to the power of 4 plus 1. And r to the power of 4 times r to the power of 3 will be r to the power of 4 plus 3. And so what is our result? Our result is, first of all, negative 8 to the power of 5 r to the power of 7. Okay, you must practice this one more time. You must be very, very clear about how to multiply these kinds of expressions. Okay, let's do another one. Find the value of the quantity 12y cubed times the quantity 4y times the quantity negative 3y to the power 5. What do you do first? First of all, we group like terms. What are like terms? Like terms, if you now look, numbers 12 times 4 times negative 3. You see, it's easy to multiply those numbers, so put them together. And then, terms that have base y, y cube, y to the power 5, group those together. That is the meaning, group like terms. So, I have indicated that by using colors. We now multiply 4, 12, 4 and negative 3 together. There you are. 12 times 4 times negative 3. Now, we group those together, and then y cubed times y to the power 5, quantities that have base 5 together. Okay, now can you tell me, what is 12 times 4 times negative 3? First of all, what will be the sign of that? 12 times 4 is 48. 48 times 3. What is 48 times 3? Is that 144? Yes? Now, so 12 times 4 is 48. 48 times negative 3 will be negative 144. So, multiplying these numbers will give me negative 144. And multiplying expressions in this base y will be, all of them have base y, so that will be y to the power of, add the exponent. Now, if you don't have an exponent there, it means it is a 1. That will be 3 plus 1 plus 5 over here. And that will be negative 144 y to the power of 9. Okay, let's move on to the next one. Find the value of 17 to the power of 0. Now, in the next lesson, I will show you the meaning of raising a number to the power 0. But at the moment, I want you to just believe me when I say any number raised to the power 0 is 1. Any number raised to the power 0 is 1. So 17 raised to the power 0 is 1. 6 raised to the power 0 is 1. X raised to the power 0 is 1. A raised to the power 0 is 1. Anything raised to the power 0 is 1. Any number raised to the power 0 is 1. X raised to the power 0 is 1. Okay, so far we were talking about product rule. How will you simplify when expressions with the same base are multiplied? When expressions with the same base are multiplied, we add the exponents. Alright, let's now talk about the second rule, which is called the power rule for exponents. Alright, let's start with this. Find the value of 3 to the power of 2. Now, all of that raised to the power of 3. Now, listen to the way I read it. 3 to the power of 2, all to the power of 3. What does that mean? It means 3 to the power of 2 is multiplied by itself 3 times. That's the meaning there. 3 to the power of 2, all to the power of 3 means 3 to the power of 2 times 3 to the power of 2 times 3 to the power of 2. Well, this can be done by using the product rule. When expressions with the same base are multiplied, what do? Add the exponents. So what will this be? 3 to the power of 2 times 3 to the power of 2 times 3 to the power of 2 is 3 to the power of 2 plus 2 plus 2. And that is equal to 3 to the power of 6. Well, looking at this, you now know there is an easier way to come to this answer. And what is this? Look at the power. 3 to the power of 2 raised to the power of 3. What all we need to do is simply multiply the powers. So that will be 3 to the power of 2 times 3, which is 3 to the power of 6. So the result can be easily obtained by multiplying the two powers. Alright? Now, sometimes students get very often confused when to multiply powers and when to add powers. Alright? I want you to learn this once and for all. Now, when will you add the exponents and when will you multiply the exponents? Now, look at this. 5 to the power of 3 times 5 to the power of 4. This time you are multiplying expressions with the same base. You are multiplying two expressions and each has the same base. In this case, you add the exponents. This will be 5 raised to the power of 3 plus 4. So that will be 5 raised to the power of 3 plus 4. On the other hand, if I have 5 to the power of 3 and I want to raise that to the power of 4, you see, the expression 5 to the power of 3 is now raised to the power of 4. Now, I normally say a power is raised to a power. You see that? It is then that you multiply the powers. What is the value of this? This will be 5 raised to the power of, that will be 5 raised to the power of 3 multiplied by 4, and that will be 5 raised to the power of 12. So you must be very sure about when to add exponents and when to multiply the exponents. Okay? Let's continue. So 3 to the power of 2 all to the power of 3 is the same as 3 to the power of 2 times 3, which is 3 to the power of 6. And this is what we call the power rule. Power rule. You raise an exponential expression to a power. Now, what does the power rule say? You have an exponential expression, a to the power of m, and raise it to a power n. What do you get? Multiply the powers, equal to a to the power of m multiplied by n. And that is the power rule. Okay, let's now simplify some expressions. Find the value of 6 to the power of 3 all to the power of 5. This is where we use the power rule. What is this equal to? That is equal to 6 to the power of 3 multiplied by 5, and that is 6 to the power of 15. Will I ask you to give me the value of that 6 to the power of 15? I don't think so. Simplify. 2x squared y cubed all raised to the power of 5. Watch the parenthesis. The whole quantity is raised to the power of 5. Now, I hope you understand this. This means each of these quantity is now raised to the power of 5. Alright, let's write that. It means 2 is raised to the power of 5. X squared is raised to the power of 5. Y cubed is raised to the power of 5. Alright, so 2x squared y cube all to the power of 5 equal to 2 raised to the power of 5 times x squared raised to the power of 5 times y cube raised to the power of 5. Alright, now we can simplify each of these. Can you tell me what is 2 raised to the power of 5? That's a very simple number. I can ask you for that. 2 raised to the power of 5. Multiply 2 by itself 5 times. That will be 32. Well, we will do that later. 2 to the power of 5. X to the power of 2. All to the power of 5. Use the power rule there. That will be x to the power of 2 times 5. And y to the power of 3 all to the power of 5 is y to the power of 3 times 5. And what's that equal to? That is 2 to the power of 5, x to the power of 10, y to the power of 15. Okay. And if you now want, you can replace this 2 to the power of 5 by 32. Okay, let's go on to another one. Alright, let's see how many of you recognize this. Negative 9 to the power of 4 all to the power of 6. Okay, first of all, let me ask you if you remember. Now, inside the parenthesis, negative, listen to the way I read it. This is negative 9 to the power of 4. Tell me, is this quantity a negative number or a positive number? Just inside the parenthesis. Now remember, this power 4 does not belong to this negative sign. It only belongs to 9. So that is negative. But that negative sign is now raised to a power 6. So we have a negative number raised to an even power. Will the result be positive or negative? The result will be positive. So negative 9 to the power of 4 all to the power of 6 will be 9 raised to the power of power rule, 4 times 6. Now, what happened to the negative sign? Alright, I want you to think about it. It is 9 to the power of 24. And I have asked you this question. Can you explain what happened to the negative sign? We actually talked about it. The negative sign becomes positive because the negative number is raised to an even power. Alright, let's do another one. Simplify. Negative 7 to the power of 5. Again, inside the parenthesis, you got a negative number. And that negative number this time is raised to an odd power. What does that mean? That number, the result will be negative. So when you simplify this, the result is going to be negative. And use the power rule over here. So negative 7 to the power of 5 all to the power of 5 will be negative 7 raised to the power of 5 times 5. The result will be negative, which is negative 7 to the power of 25. Why didn't the negative sign disappear this time? The negative sign did not disappear this time because the negative number is raised to an odd power. Very wrong. Another one. Simplify. Quantity 9xy. The quantity 9xy raised to the power of 5. What that means is 9 is raised to the power of 5, x is raised to the power of 5, and y is raised to the power of 5. So that is 9 to the power of 5, x to the power of 5, y to the power of 5. Okay, let's move on. Simplify. A over b all to the power of 6. It means a is raised to the power of 6 and b also is raised to the power of 6. So a over b all to the power of 6 is a to the power of 6 divided by b to the power of 6. Another one. Same kind of problem. 7 over 8 all raised to the power of 5. What would that be? That will be 8 to the power of 5 divided by 7 to the power of 5. Let's move on. How about this? 3 over 4 raised to the power of 6 multiplied by 3 over 4 raised to the power of 7. Now tell me, what will you do here? If you notice, this is the base, this is the exponent, this is the base, this is the exponent. The bases are the same. When you multiply expressions with the same base, what do? Add the exponents. So 3 over 4 raised to the power of 6 multiplied by 3 over 4 raised to the power of 7 is now raised the same base to the sum of the two powers, equal to 3 over 4 raised to the power of 6 plus 7. That is 3 over 4 raised to the power of 13, which is the same as 3 to the power of 13 divided by 4 to the power of 13. Okay? Alright, let's move on. What is 7 over 5 all to the power of 5 multiplied by 7 to the power of 3? Now, can you use the product rule here? Well, no, because in the first expression the base is 7 over 5. In the next one the base is 7. The bases are not the same. You cannot use the product rule there. Alright, let's simplify the first one. Now, 7 over 5 all to the power of 5 can be written as 7 to the power of 5 divided by 5 to the power of 5. There you are. So, this is 7 to the power of 5 divided by 5 to the power of 5. And watch how I write 7 to the power of 3. I write it as 7 to the power of 3 divided by 1. I wrote it with the numerator-denominator form. Does it make any difference? No. Any number can be written as that number divided by 1. Now, what is the advantage here? Now, the numerators contain 7 to the power of 5 and 7 to the power of 3 are on the numerator. And the denominator is 5 to the power of 5. So multiply the numerators. What is multiplying the numerators give you? That will be 7 to the power of 5 times 7 to the power of 3 on the numerator, divided by 5 to the power of 5. And now, on the numerator, we can use the product rule, because the bases are now the same. What is 7 to the power of 5 multiplied by 7 to the power of 3? That will be 7 to the power of 5 plus 3 over 5 to the power of 5. And that is, the answer now is 7 to the power of 8 divided by 5 to the power of 5. Another one. Simplify. The quantity negative 8p all raised to the power of 5 multiplied by the quantity negative 8p squared Now, you've got to watch that carefully. Whereas, this power 5 belongs to the number -8 as well as p. Watch here. This power 2 only belongs to p. It doesn't belong to -8. Okay, how do we simplify this? First of all, we give this power 5 to each of these numbers. So that will be the number -8 raised to the power 5, p raised to the power 5, times -8p squared can be written as -8 times p squared. Right? Okay. Now if you look, we can combine like terms. Now what is the definition of like terms? Terms that contain the same base. Now if you look here, the base in the first case is -8. -8 raised to the power 5. And do we have another number with base 8? Yes. This is -8 raised to the power 1. When there is no power written, it is raised to the power 1. So we can now combine these two and then combine expressions with base p. So group like terms. How will that be now written? It will be -8 raised to the power 5 times -8 raised to the power 1. You can see I'm reading it as raised to the power 1, although there is no 1 there. We have grouped numbers with base 8 together. And now p to the power 5 times p squared. Okay, can you now combine these two? What is -8 to the power 5 times -8 to the power of 1? Apply the product rule, not the power rule. Now, I want you to change this. This is not the power rule you're going to apply there. You're going to apply the product rule. Okay. Now, when you apply the product rule, this is the product of -8 to the power 5 times -8. What would that be? That will be -8 to the power of 5 plus 1. And this will be p raised to the power of 5 plus 2. Alright. So, let me take away that step. And that will be -8, the same base, raised to the power of 5 plus 1 times p to the power of 5 plus 2. And that is -8 raised to the power of 6 times p to the power of 7. And now you notice this. The number -8, the base -8, is raised to the power of 6. The power is even. When a negative number is raised to an even power, the result will be positive. So, this will be 8 to the power of 6, p to the power of 7. I hope you understand this transition. -8 to the power of 6 is the same as 8 to the power of 6. Okay, let's look at another one. Simplify. X to the power of 3 all to the power of 6 multiplied by x to the power of 2 all to the power of 3. Now tell me, what is the first rule we are going to apply here? Here you actually need to apply both the rules, the power rule and the product rule. Which of them you will use first? If you watch here, the first expression is an exponent raised to a power. So use the power rule to simplify this. What is x to the power of 3 raised to the power of 6? Tell me, what is x to the power of 3 raised to the power of 6? That will be x to the power of 3 times 6, 18. And now, what is x to the power of 2 raised to the power of 3? Is x to the power of 2 times 3. That's right. So this is now x to the power of 3 times 6 times x to the power of 2 times 3. And that is x to the power of 18 times x to the power of 6. Now, it is at this time you say, I am now multiplying two numbers that have the same base. And therefore I use the product rule here. Because the bases are the same, I add the exponents. So this time we use the product rule. That will be x to the power of 18 plus 6. And that is equal to x to the power 24. Okay, we actually gone through a spectrum of examples using the product rule and the power rule. Let's try this one. Okay, let's see how many of you can follow this. Look at the quantity, 3x to the power 4, y squared, z cubed, all to the power of 3, multiplied by 2x squared, z squared, all to the power of 3. What will you do here? In the first case, we give this power to each of these. So this power 3 belongs to each of these. It is 3 to the power of 3, x to the power of 4 raised to the power of 3. Let's write that down. So this quantity is 3 to the power of 3 times x to the power of 4 raised to the power of 3 times y to the power of 2 raised to the power of 3 times z to the power of 3 raised to the power of 3. Alright, we finished with the first quantity. And now let's go to the next one. 2x squared, z squared, all to the power of 3. Right? Now, raise to the power 2. 2 to the power of 3, that's this one. X to the power of 2 raised to the power of 3, that is this. Z to the power of 2 raised to the power of 3. Okay, what is the next step? You notice there, you can now combine, you can now use the power rule. Look at the power rule we're going to use. X to the power of 4 all to the power of 3 is x to the power of 4 times 3. And y to the power of 2 all to the power of 3 is y to the power of 2 times 3. Z to the power of 3 all to the power of 3 is z to the power of 3 times 3. Alright, let's go on there. 2 to the power of 3 we will leave as it is. X to the power of 2 all to the power of 3 is x to the power of 2 times 3. And z to the power of 2 all to the power of 3 is z to the power of 2 times 3. See, look at the way we use the product rule. Let's simplify that. That will be 3 to the power of 3 times x to the power of 12, y to the power of 6, z to the power of 9 times 2 cubed, x to the power of 2 times 3 is 6, multiplied by z to the power of 2 times 3 is 6 again. What will be the next step? Combine like terms. Look at that. Write the numbers first. 3 to the power of 3 times 2 to the power of 3. They are both numbers. And then write numbers with the same bases together. X to the power of 12 times x to the power of 6. They are like terms. Now write numbers with the same base y. Y to the power of 6 is the only one. And now z to the power of 9 times z to the power of 6. We have written numbers with the same base together. And now, in each of this case, look at this. X to the power of 12 times x to the power of 6 is x to the power of 12 plus 6. And I also did one more thing. 3 to the power of 3 is 27 times 2 to the power of 3 is 8. X to the power of 12 times x to the power of 6 is x to the power of 12 plus 6, and y to the power of 6, and z to the power of 9 times z to the power of 6 is z to the power of 9 plus 6. And now write our final result. What is 27 times 8? Is 216 times x to the power of 12 plus 6 is 18. Y to the power of 6, z to the power of 9 plus 6 is 15. That is a beautiful problem, and I want you to go back and do that one more time. Okay? Let's now simplify one more expression. 3a squared b cubed all over c to the power of 4 all raised to the power of 3. What will be the first task that we need to do in simplifying this? Well, the first task is give this power 3 to each of the numbers here. Raise to 3 to the power of 3. Raise a squared to the power of 3. Raise b cubed to the power of 3. And raise c to the power of 4 to the base 3. Let's do that. Now, that is 3 raised to the power of 3 times a raised to the power of 2 all raised to the power of 3. B cubed raised to the power of 3. They are all on the numerator. Divided by c to the power of 4 raised to the power of 3. We take each quantity and raise it to the power of 3. What is the next thing we can do here? You see here, each of these quantities is an exponent raised to a power. We can now apply the power rule for each of these. Use the power rule to simplify each of these. That will be 3 to the power of 3 will remain as it is. A to the power of 2 all to the power of 3 is a to the power of 2 times 3. B to the power of 3 all raised to the power of 3 is b to the power of 3 times 3 over c to the power of 4 all raised to the power of 3 is c to the power of 4 times 3. And that will be 3 to the power of 3. A to the power of 2 times 3 is 6. A to the power of 6. B to the power of 3 times 3 is 9. Over c to the power of 4 times 3 is 12. Well, the only other step we can do is 3 raised to the power of 3 is 27. And you cannot do any other simplification, so we leave it as it is. The result is 27a to the power of 6, b to the power of 9, over c to the power of 12. Okay, I hope you got a good grounding on the product rule and the power rule and how to simplify these expressions using those two rules. In the next lesson, we will see another rule for simplifying exponents. It's called the quotient rule. What's a quotient? Quotient is a quantity divided by a quantity. Now, when you have an exponent divided by the exponent with the same base, how will you simplify that? That is the quotient rule. We will see that in the next lesson, and then we will simplify problems using all these three rules. Okay, I will see you for that in the next lesson a little while later.